Hello everyone, I'm Mr. Furlong, and today we're talking about energy. It takes a lot of energy in order for a muscle to contract. And of course, that energy is coming from an ATP molecule. That is short for adenosine triphosphate. But we don't have a whole lot of ATP in our muscle tissue, and it breaks down into ADP. And so we need to get that quickly regenerated back into ATP again so that we can continue to move our muscles. So how do we go about doing this? Well, if you recall, this happens through the process of cell respiration. So in the mitochondria of the cells, the food that we eat, things like glucose or fatty acids and glycerol, will make their way into the mitochondria. It goes through glycolysis and Krebs cycle and electron transport, and we get roughly about 36 ATPs for every glucose molecule that we can use to move our muscles. But that may not even be enough. So we have another molecule that is stored in our muscle tissue called creatine phosphate. And ADP can borrow some of the energy that's stored in between those phosphate bonds in order to regenerate the ADP back into ATP. Now, there might be some times where we are just using our muscles so much that this isn't going to supply us with enough energy. We know that in order for cell respiration to take place, though, there has to be oxygen. So, of course, we're having plenty of oxygen coming into those cells, but if we're using up so much oxygen so quickly, it might not be enough. To help us out, we store some oxygen in the form of myoglobin. This might sound familiar to you. We have a protein in our blood called hemoglobin, which carries oxygen to our cells. Myo, meaning muscle, simply stores oxygen in our muscle tissue. I'm sure you're familiar with myoglobin. In red meats, it's what makes the meat red. So that juice that comes out of a well-cooked steak, well, that's not blood like many people think. That's the myoglobin protein. And just like blood does, when oxygen comes in contact with hemoglobin, it turns it red. Myoglobin is the same way. It turns kind of a reddish color. So here's the problem, though. If we're really using our muscles a lot, we're being very active, we might not be able to get enough oxygen to our cells in order to make enough ATPs to keep those contractions going. And so we can develop what is called an oxygen debt. And just like any debt, it's got to be paid. So what typically happens in an oxygen debt situation, the glucose changes into pyruvic acid, right, which is the stages of glycolysis. This is what normally happens. This does occur without any oxygen being needed, but that pyruvic acid, which normally goes into acetic acid and can go into the Krebs cycle, changes into lactic acid. The lactic acid starts to build up, and it can cause your muscles to begin to cramp up. So if you've ever experienced a muscle cramp, it's due to not getting enough oxygen to those muscle cells. It's kind of your body's way of saying, slow down a little bit here. But sometimes this happens when we're dead asleep. Maybe you've woken up in the middle of the night and your legs are just cramping up. Well, when you think about it, it kind of makes sense because when you're sleeping, your heart rate goes way down, your breathing rate decreases, the amount of oxygen that you're breathing in decreases, and let's say that you have a blanket on you and your muscle is contracted, and that needs to stay contracted because you're not moving. That requires energy. Pretty soon you're not getting enough oxygen to those muscle cells. They begin to build up lactic acid, and you wake up in the middle of the night with a leg cramp. Another time you might experience this is maybe when you're running. If you've ever experienced that stitch in the side, that is your diaphragm that is cramping up. And again, it's your body's way of saying, slow down a little bit, or breathe more, will ya? Because what can happen if we continue to go is it can cause muscle fatigue. And this is where our muscle temporarily loses that ability to contract. And so we just can't do that activity for a while. So getting enough oxygen to the cells, having enough ATP for muscle contraction is what keeps our muscles working well. And just to give you a little something to look forward to, we just might be doing something in class to fatigue some of our muscles. I'll see you then.